In this video, we're going to calculate inverse trigonometric functions. The first example is given cosine theta equals 0.823. Find the value of theta. State your answer in degrees, correct to 3 significant figures. So we were given cosine theta. So cosine theta equals 0.823. Now we'll just take a look at the calculator, and to find the value of theta, we'll get the inverse cosine function, inverse cosine 0.823. Now, before I go on, I just want to point out we have d up at the top of the calculator, which means the answer returned will be in degrees. So we've got 34.61, and I need to check what the 6137. So we were asked to give it in degrees to 3 significant figures. So 3 significant figures. The first is 3, the second is 4, third one is 6, and it's followed by 1, so we leave it at that. So 3, this is degrees, 3 SF. So that's the first problem complete. So let's take a look at the second example. In example 2, we're told that tan theta equals 1. Find theta without using your calculator. So let's take a look at this one. Tan theta equals 1. I'll just move it over here. Tan theta equals 1. Now we're asked not to use our calculator. If I did tan inverse 1, I would get the correct answer. But if you consider tan is opposite over adjacent in the right angle triangle, we can just draw a right angle triangle, and we will consider opposite. So if this is theta here, tan theta is opposite over adjacent. So the opposite would be 1, and that means the adjacent must be 1. This is the right angle triangle, which in effect gives us, if we've 1 here and 1 here, this must be an isosceles triangle where this is also theta. So we can calculate theta by saying 2 theta plus 90 degrees, our right angle triangle, must equals 180 degrees. And theta therefore equals 180 minus 90, which we know is 90, all divided by 2. It gives us theta equals 45 degrees. Now, if I was to check that on the calculator, I would actually just put in tan inverse, so shift tan 1, and that will return 45 degrees. So we've got the correct answer. Now let's take a look at the last example. Example 3. The area of the following triangle is known to be 10 meters squared. Find the angle at C. So we're given a triangle. C is the inclusive angle between lengths 4 meters and 6 meters. So let's take a look at that problem. And I'll just quickly sketch the triangle again. So we had, I think I have to delete that one, start again. We had 4 meters, and we had 6 meters, and here was the angle we're interested in. And I'll just complete this triangle like this. We're told the area equals 10 meters squared. Just do that again. Area equals 10 meters squared. So if we put that into our formula for our area, we've got half each of the lengths, 4 times 6 times sine theta, or sine c in this case, equals 10. So we're going to have sine, well, half, that will simplify to 12 sine c equals 10. So sine C is 10 over 12, or 5 over 6. We want to simplify that down. And we now need to say C equals sine inverse 5 over 6, and we'll do that on the calculator. And the calculator here, we'll just clear the last working. So clear the shift sine inverse 5 over 6. So it gives us an angle in degrees of 56.4. That's 3SF. That's the last problem solved. So that's all for this video. Thanks for watching.